Cosmology, a real frontier. These are the voyages of the Smash News Network, least busted name in news, our continuing mission to report cosmology facts and to talk about interesting objects. We've got quite a few of them, so won't you join us? First thing we're going to look at is cosmic ray monitors. Yeah, cosmic ray monitors. Cosmic rays affect things like errors in computers. Veritasium recently did a video about it. Go check that out if you haven't. He certainly doesn't need our help. He's got millions of subscribers. This is the last 30 days of cosmic ray flux at the Apatomy Neutron monitor, and you can see a mild reduction there in cosmic ray flux at Apatomy. Barentsburg, a similar downward tick, and to those of us who understand the relationship between solar activity and cosmic ray flux, it's probably no surprise as solar activity has been quite high. Next, we'll go farther south and look at some more reliable cosmic ray monitors like Athens Greece. There's the Athens Greece neutron monitor, a similar downtick there at Athens Greece. Going even farther south to Mexico City, we see a slightly flatter graph, but certainly a similar downtrend in the past 2 weeks. These are all 30-day charts that we're focusing on here, and next we'll go back up north to Oulu, Finland. This is in alphabetical order if you're wondering. You can see a mild downtick at Oulu. And now going as far south as she goes, DOMB's reporting nothing over the past 30 days, and DOMC is showing a similar downward trend. So that's not really a big surprise there, folks. Seeing this reduction in cosmic ray flux, it is always correlated with solar activity. So there's an inverse relationship between solar activity and cosmic ray flux. Let's move on. To some incredible imagery. So yeah, here's Comet Leonard. Pardon that little momentary delay. Here's Comet Leonard, which has been outbursting, and it hasn't reached its closest point to the sun. So this thing may become visible to the naked eye again. I sort of doubt it, but it's begin outbursting, and you can see different plumes coming out of it here. One is likely an ion trail, and one is likely just gas and dust. So you're probably looking at a combination of different types of plasma. And in space, basically everything is plasma. Because in space, if you're not inside a magnetosphere, you're getting hit by ionizing radiation all the time, which means most stuff in space is plasma. So to suggest that anything is interesting because it's made of plasma is just ridiculous, because the entire trail of this, the whole tail of this comet, is indeed likely plasma. Material in space only needs to be like 20% ionized to be considered, quote, plasma, end quote. Because when you're standing here on the planet on the surface of the Earth, what you consider a neutral molecule is a neutral molecule. Everything's ionized in space because it's getting bombarded by radiation as well, electromagnetic radiation as well as particles. And so anyway, Comet Leonard, you can see the ion trail with magnetic fields in the solar wind. So this is an interactive situation that's going on here in a lot of different ways, not only the interaction between the gravity and so on. There's also a lot of forces at work here that are only, becoming moderately understood. Anyway, fantastic imagery there of the nucleus. And you can see it looks like a bow shock because it has a magnetosphere, I would probably have to say. Otherwise, why would the ion tail be doing that? Next, a random number. Our cosmology segments regularly have random numbers. And let me just check the life of the stream here. Again, we did stream this video live, folks. Live to twitch.tv/smAsho. Today's featured object is number 360 at the Neil Gehrels Swift Bat X-ray Observatory, which is one of my personal favorites, Quasar 4C01.28. So it's a pretty easy, catchy name to remember, 4C01.28. And here are the last 30 days of its hard X-ray output. It's a distant, distant galaxy, and let's zoom in, because it's out there. It is out there, folks. So when we zoom in, and I mean way in, I mean way, way in, there's a visible analysis of that, that distant galaxy with its polar field oriented toward us. Quasar 4C01.28. Now, if you look at it in other frequencies here, let's see if we can see it in X-ray. How about the false color imagery? And there it is in X-ray. You can see it's quite a bright X-ray source. Now, this typically happens when you've got a galaxy. You know, galaxies are roughly shaped like this, if you view them edge on. And they often have a particle stream coming out of the poles, where the combined output of a bunch of stars is aligned toward the center of it. And if you're viewing this galaxy from like this location, or if it's producing a thing like a flux tube, if you're viewing it from the edge of this flux tube of material flying out of that galactic core, you get a different view of it than if you view the galaxy from this sort of a perspective. In other words, it looks completely differently depending on the perspective from which you're viewing it. So that's my point. If we look at it in infrared, it'll look totally dark, probably. Oh, there is a little bit of a heat signature there. There it is in infrared. You got to zoom even farther in. But it's a very distant galaxy, and that's sort of what a quasar is. It's a galaxy with a specific orientation. That's why they look so bright in X-ray at such a long distance. So anyway, there it is once again. That's 4C01.28, the quote random end quote object of the day. That's today's cosmology segment. We don't always do them. We don't always separate them from the space weather video. Many of them are integrated in the daily space weather video. Another reason to watch the videos on YouTube if you don't otherwise. In any case, thanks for tuning in. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, and happy Christmas from the least busted name in news.